Hey everyone, and welcome to The Explainer. Today, we're diving headfirst into one of the biggest mysteries in the tech world right now. We're talking about what is, without a doubt, the most anticipated consumer electronics release of the decade. I mean, competitors have been tweaking and iterating on their devices for years at this point, yet the absolute biggest player in the space? Total silence. They've just been waiting in the shadows. We are, of course, talking about the elusive foldable iPhone. But seriously, why the wait? What is the massive engineering hurdle that has kept a multi-trillion-dollar company from just jumping into the fray?
It's a question on literally every tech enthusiast's mind. Why hasn't Apple released a foldable phone yet? Rivals like Samsung are already gearing up for their 8th generation of folding devices. You'd think Apple would have jumped in by now to claim their piece of the pie, right? But they haven't. And despite years of rumors, leaked patents, and endless speculation, Apple has intentionally stayed on the sidelines. And here's the thing, they aren't waiting for the market to mature, and they aren't waiting for consumer interest to peak. They have been waiting to solve one highly specific, incredibly stubborn physics problem.
The core problem holding them back is actually pretty simple. There's this one design flaw that just refuses to go away. The crease, right smack in the middle of the screen. You know the one. That visible, tactile line running right down the center of the display has been the absolute bane of foldable phones since day one. Multiple reports indicate that Apple demands a near crease-free screen before they will ever launch this rumored iPhone Fold. They flat out refuse to compromise on display quality. So to really understand how they plan to fix this, we have to understand why that annoying crease forms in the first place. All right, Section 1, the science of bending.
Okay, let's dive right into this. To truly grasp the magnitude of this challenge, we need to zoom way in. We're going to move past the macro view of that sleek phone in your hand and dive deep into the microscopic physics of a bendable display. Because the mechanics of folding a screen are far more violent and stressful on the materials than you might think. In a simplified multi-layer stack-up of a foldable display, notice those polycarbonate layers? They are incredibly thin, just 25 microns each. To put that into perspective, that's roughly a third the thickness of a human hair. But the unsung hero of this entire assembly is sandwiched right in the middle, the soft optically clear adhesive, or OCA. This tiny 50-micron layer of glue is responsible for holding these extremely delicate display layers together while they are literally being bent in half.
When you fold that screen, you are unleashing absolute chaos on those microscopic layers. The red areas on this contour plot vividly illustrate exactly where the phone is experiencing the most trauma. The highest strain in the OCA layer occurs right at the transition between the unsupported central hinge area and the region bonded to the phone's rigid housing. As the display bends, the materials are stretching and sliding against each other, creating just massive amounts of shear strain.
Which brings us to Section 2, the secret hero, OCA.
So the crazy part is that the glue holding everything together is actually the single most important factor in the entire device. The mechanical properties of the OCA are the absolute most critical parameter in determining if a screen is going to survive repeated folding or if it'll develop a permanent ugly crease. To understand the OCA, you really need to understand viscoelasticity. See, this glue isn't just a solid and it isn't just a liquid. It's kind of both. When you deform it by folding the phone, it exhibits elastic, solid-like characteristics, meaning it desperately wants to bounce back to its original shape. But it also exhibits viscous, liquid-like characteristics, meaning it flows and dissipates energy over time. Let's see how this all builds up when we put this viscoelastic material into a real-world testing scenario. To test if this glue will actually survive the real world, researchers put it through a totally torturous cyclic load test. It simulates how we honestly abuse our phones every day, snapped shut in 2 seconds, held under immense stress in your tight pocket for 20 seconds, whipped open in 2 seconds, and then held flat for another 20 seconds. This cycle is repeated over and over and over to see how the trauma of folding actually compounds the stress on these microscopic layers. And this right here brilliantly illustrates the core problem with the crease. Because the glue is viscoelastic, it takes time to recover from the stress of being bent. In fact, simulations show it takes about 120 seconds for the stress to fully stabilize and for the material to heal, so to speak. But in our 44-second cycle, it's only getting 20 seconds of rest. The result? Residual stress. The stress literally doesn't have time to return to zero before the next fold happens. It just adds up cycle after cycle, physically fatiguing the materials and permanently deforming the display. That fatigue stress is exactly what causes the visible crease you see on the screen. Moving on to Section 3, Samsung's metal plate. Okay, now that we know why the crease happens, let's pivot from the problem to the highly anticipated solutions, because we are starting to see some massive material science breakthroughs here. At their CES 2026 booth, Samsung actually put this new prototype panel right next to the older Galaxy Z Fold 7, and you guys, the difference was night and day. They achieved a completely crease-free foldable OLED panel promising seamless text across the fold. So how did they do it? The secret is a brand new hardware fix, a laser-drilled metal display plate sitting right under the screen. This plate is specifically designed to diffuse and spread out the stress created when the screen folds, basically preventing that localized shear strain that causes the crease in the first place. And this huge breakthrough is heavily expected to make its way into the upcoming Galaxy Z Fold 8.
Section 4, Apple's high-tech glue. This brings our detective story right back to Apple. With Samsung achieving a crease-free screen through a laser-drilled metal plate, how does Apple plan to counter this hardware breakthrough for their long-rumored 7.8-inch foldable? Well, we are looking at two completely different engineering philosophies to solve the exact same physics problem. While Samsung is relying on a supporting metal plate to spread the stress, Apple is attacking the materials themselves. According to reports, Apple's approach involves chemically strengthening and actually thinning the ultra-thin glass right at the bending axis to improve flexibility while keeping the rest of the glass nice and thick for impact resistance. But the real magic? That lies in their use of incredibly advanced, next-generation optically clear adhesive. A recent TrendForce report revealed that Apple's new high-tech OCA glue takes that viscoelasticity we talked about earlier to a whole new level. Because of its unique micro-flow characteristics, the adhesive literally flows over time to fill in the microscopic gaps and irregularities that form in the display layers after long-term folding. By acting slightly more liquid over time, it smooths out the internal structure of the screen. This minimizes light scattering and pretty much magically hides the crease from the naked eye. It is just such an elegant, chemistry-driven solution to a purely mechanical problem. Finally, Section 5, the crease-free future. So we have Samsung's laser-drilled metal plates on one side and Apple's micro-flowing variable thickness glass on the other. Let's talk about what these massive material science breakthroughs actually mean for the consumer tech market as these devices finally prepare to launch this year. Listen, the moment Apple finally steps into the foldable arena, the whole landscape is going to shift violently. Industry analysts at TrendForce predict that Apple will immediately capture a staggering 20% of the entire foldable smartphone market the very second their device launches. Despite being years late to the party, solving this crease issue is expected to instantly win over a massive chunk of premium smartphone buyers who have just been holding out for a flawless experience. But let's ground this cutting-edge tech back in consumer reality for a second. Developing micro-flowing viscoelastic glues and laser-drilled metal plates, yeah, that is not cheap. When the iPhone Fold, or iPhone Ultra as some are calling it, finally hits the shelves, this flawless engineering is going to come at a very steep price. Analysts are predicting a starting price tag of around $2,000, with some estimates reaching all the way up to $2,399. We've gone from the macro all the way down to the microscopic strain on a 50-micron layer of glue, all in this epic quest to kill the crease. It is an incredible engineering journey that shows just how incredibly hard it is to bend glass and electronics without breaking them. But it leaves us with one final, very important question for you to consider. Knowing the intense science involved and looking at that steep $2,000 price tag, is a completely crease-free screen finally enough to make you switch to a foldable phone? Let that sink in. Thank you so much for joining me on this explainer, and definitely keep an eye out for these flawless screens hitting the real world soon.